Hey guys, this is an addition I'd like to make to the premium course on volumes, because I think this one might be relevant to some of you in production. So this came up in a discussion I had where someone was trying to fade out a volume along a given axis in order to kind of style a simulation according to client feedback. And here's my take on how I do that. So let's look at this slice through a volume here with all those individual voxels, and they contain some density values in our case. And in order to fade out or fade in those values, what I'd like to do is I'd like to multiply them with a value ranging from 0 to 1. And you could think of that as an opacity value, ranging from 0, totally transparent, to 1, fully opaque. And to control the direction and the length of our fade out, what we're going to do is we use a curve, a line containing only 2 points, a start and an end point here. And what I want to do in this example is look at a single voxel, in our case this one here, the orange one, and let's just look at it from its center here. And the first thing we want to do is determine the closest position to that voxel that is on our line. So basically, what is the shortest distance from any point that is on the line here towards the voxel center here? And that's what this purple arrow here represents. So just find the shortest distance from any given point on the line to the voxel. So in our case, let's only look at the control line and the purple point here. That's the point with the shortest distance to our voxel here. And what we do now is for each axis, the x and the y axis, we remap the purple point's x and y position in respect to the first and the last point of our control line here. The first point being 0, the last point being 1 along the x and the y axis. So in our case, this would yield an approximate value of 0.1 along the x-axis and also a value of 0.1 along the y-axis in our case. So the final thing that we have to solve is how do we combine these axis values with a third axis, a z-axis that we have in three-dimensional space. And my approach here is to take the minimum value of each of those individual components, so the minimum value of the x, y, and z component, remapped between 0 and 1. Let me show you what I mean. So in Houdini, what I'll do is create a GeoNode, dive in there, delete the file, and drop down a pighead test geo in our case. Set the difficulty to easy, and then append a VDB from polygons. And here I just want to create a fog VDB, and I want to fill the interior like this here, and then just append a volume wrangle in which, just for demonstration purpose, I'll set each and every density in each voxel to be equal to 1, like this. And maybe let's increase the VDB resolution by decreasing the individual voxel size like this. So now I have a high-res VDB containing only ones, like a really uniform fog volume. Now let's create a line to use as a controller for our fade out ramp. Let's ghost this and maybe bring down the origin a bit and increase the overall length a bit, like so. So just a line pointing upwards. Next, I'm going to drop down a volume wrangle, wire in the volume that I'd like to ramp, and my controller line as a second input here. The first thing that I have to do is find the shortest distance from each voxel towards any given point on that line here. And in order to do that, I'll use a function called minpos. So let's create a vector. Let's call it shortest position, and should be equal to minpos of something. Let's just head to the help. And we can see that minpos requires 2 arguments. On the one hand, a geostream telling it where to look for this closest position, and then a vector containing a position from which it should look for the shortest distance to a point on the surface. So we want to look on the surface. That means the spline coming in through this slot here. That's the slot with the ID 1. And we want to look for a closest point on that spline from our given voxel position, which is encoded in our P position here, like this. Let's highlight it. That works. Next, what I'll have to do is remap this position that we just found on this line here, which is just a three-dimensional vector containing x, y, and z values. So it's not necessarily between 0 and 1. So we'll have to remap that to values of 0, 0, 0 to 1, 1, 1. In order for that, I need the start and end point of my line here, which I can get in a very manual way, for example, using the point function. And I want to look up on my geostream with the ID 1. I want to look up the attribute called P, and I want to look it up on the point with the point index with the point number 0. Let's just copy this line here, paste it down here, and for the end position. Let's do the same thing, just look at the point with the point number 1. Now I've got my 3 positions, the start and end position of my line here, and the point that lies on this line with the shortest distance to my individual voxel. Next, let's use a fit function to transform the global coordinates of that shortest position into the 0 to 1 space that we need. Let's call this one remapped position, and it should be equal to something that the fit function spits out. And the fit function needs 5 arguments. First, the value it should remap, in our case the shortest. Pause. Next, it needs the min and maximum input values. So the start pause should be our minimum input values, and the end pause should be our maximum input values. And finally, it needs the minimum and maximum output values. So basically the target space to which we are remapping. And in our case, it should be between 0 and 1 for each component of this vector. Now let's turn this vector remap position into a float value. Call this one opacity. And as I already mentioned, for that I want to use the minimum function. So given a bunch of arguments here, this will always spit out the argument with the minimal value. Also, when I go to the help page of this, we can see here that we can just write something like min of a vector, and that will spit out the minimum component of that vector. So I don't have to write min of remap pos.x, remap pos.y, remap pos.z, but I can just write down min remap pos. So this will return the minimum component out of the remap pos. Now finally what I do is, in this volume wrangle, I will take the density value and multiply it with the opacity. Let's drop down a volume visualization and increase the density scale so we can see a bit better here. And let's play around with our line settings here, for example, the length. So I can see the ramp does not end as abruptly or really abruptly, depending on the length setting. Also, let's drag down the origin a bit and just check so that it works along each axis. So really simple way to generate a ramp and use that to drive the opacity of a given volume. Just one of those production hacks. And when you look at it, this has been used to create the example volume. And it's just these 2 nodes here, your controller, and then those few lines of code here that enable you to really be able to art direct your volumes. So that's this. I hope that's useful for you guys in production and wondering how you'd pull off something like that. Really short, really easy trick to be able to art direct your volumes a bit better and a bit more intricate. See you next time, and it's cheers and goodbye.